Here's some help with drawing the electron dot formula of covalent molecules. The electron dot formula shows you how atoms are sticking together to form a molecule. So the question says, draw the electron dot formula for each of the following molecules. And we'll start with I2. So the first thing is to draw the atoms that you have. Now here we have 2 iodines, so I'll draw 2 iodine atoms. Then we want to draw the valence electrons around each atom. So for iodine, because iodine is in column or group 7A, it has 7 valence electrons. And so we're going to draw those electrons around each iodine, 7 of them. Now when you do this, you imagine the atom is having 4 sides, and we're going to put an electron on each side first before we start pairing them. So for example, for the iodine on the left, you'd have 1, 2, 3, 4, and now that I have 1 on each side, I can start pairing them, 5, 6, 7 valence electrons. For the iodine on the right, you'd have 1, 2, 3, 4, 5, 6, 7 valence electrons. And now notice that each iodine has an unpaired electron. Unpaired electrons are unstable. So what you can do is pair them up. If these 2 iodines each share their unpaired electrons, then they have all of their electrons shared, and the atoms are stable. Now, those 2 electrons that are being shared are making the atoms stick to each other. They're binding the atoms to each other. And because of that, those 2 electrons that they're sharing are called a bond. And to show that they have this special function of making the atoms stick together, of binding them together, we draw them, instead of as 2 dots, we draw them as a single line. So that single line is representing the 2 electrons, one from each iodine, that were unpaired, but that are being shared so that each atom has all of its electrons paired. So that is the electron dot formula for the molecule I2. And I2 is used as a topical antiseptic. So before or after you give shots, or nurses or doctors give shots, they often wipe down the area with iodine to help sterilize it. Alright, the second molecule is NCl3. We'll start with the first atom, nitrogen. We only have 1 of them, so we'll just draw 1 nitrogen. Then, nitrogen is in column 5A. That means it has 5 valence electrons. So we're going to fill those electrons in around nitrogen. So 1, 2, 3, 4, 5. Okay, next, we have 3 chlorines. I'm going to draw a chlorine on each side of the nitrogen that has an unpaired electron. So 1 on the right, 1 on the bottom, and 1 on the left. The electrons on the top are paired, so I won't put a chlorine there. Next, chlorine is in column 7A. So chlorine has 7 valence electrons. So I'm going to draw those in. Now, where you start drawing them, just as a tip, if you are going to create a bond, if you know where you're going to create your bond, start drawing and you're going clockwise, if you're filling the electrons in clockwise, start drawing the dots, the electrons, at the side after where you want to fill the bond, rotating around. So here we'd want to fill the bond to the left of the chlorine. Going clockwise, the next side would be the top. So that's where we put our first electron. That's where we'd start. And by doing that, we'll end up with the unpaired electron facing the other unpaired electron on nitrogen. Okay, so we have 1, 2, 3, 4, 5, 6, 7 valence electrons along that chlorine. Now here on the bottom chlorine, we want the unpaired electron to be facing up. So going clockwise, we'll start filling in the electrons on the right side. So we have 1, 2, 3, 4, 5, 6, 7 valence electrons on that chlorine. For the chlorine on the left, we want the unpaired electron to face the right. So going clockwise, the next side of the chlorine would be the bottom. That's where we'll put the first electron. So 1, 2, 3, 4, 5, 6, 7 valence electrons. And again, we put 7 dots around chlorine because chlorine is in column 7A on the periodic table. Alright, now that we've drawn each of the atoms and the valence electrons around each atom, we need to look at which electrons are unpaired. On the nitrogen, we have 3 of those. On the chlorines, on each chlorine, we have 1. So what we can do to make those unstable, unpaired electrons stable is to pair them up. So we can take those 2 on the left and pair them up, those 2 on the bottom and pair them up, and the 2 on the right and pair them up. Those electrons that are paired are now making those atoms stick or bind together. So those are going to be bonds. And so instead of drawing them like this as dots, to show that they have this special function of binding the atoms together, we're going to draw them as a single line. So we'll replace the 2 dots with a line, replace the 2 dots with a line, replace the 2 dots with a line, and that is the electron dot formula for NCl3. So if you were to take nitrogen and mix it with chlorine in just the right way, you would get that molecule, NCl3. And it's something that forms naturally in small quantities in public swimming pools when the chlorine that's in the water reacts with people's sweat or also with urine. Okay, the third molecule is SiF4. So let's start with the first element, Si. We only have 1 of those. There's no subscript, so there's only 1. So we'll write Si. Now let's put the valence electrons around the silicon. Silicon is in column 4A, group 4A, so it has 4 valence electrons. So 1, 2, 3, 4. Now, we have 4 fluorines. I'm going to put one on each side of the silicon that has an unpaired electron. So 1, 2, 3, 4. Now, fluorine is in column 7A, so it has 7 valence electrons. If we want the bond for this right fluorine to be on the left, going clockwise, the next side will be the top. So that's where we start filling the dots in. So 1, 2, 3, 4, 5, 6, 7. And you can see that by doing that, we have the unpaired electron on fluorine facing the unpaired electron on silicon. For the bottom, we want the unpaired electron to be on the top. So going the next over clockwise is the right. That's where you'd start filling them in. 1, 2, 3, 4, 5, 6, 7. And so now we have this unpaired electron facing on fluorine facing the unpaired electron on silicon. For the fluorine on the right, we want the unpaired electron to be facing to the right. So the next side, which is down, going clockwise, is where we want to start filling in the electrons. So 1, 2, 3, 4, 5, 6, 7. And by doing that, you can see that the unpaired electron on this fluorine is facing the unpaired electron on silicon. Finally, for the top fluorine, we want the electron to be facing down. So if you're going clockwise, the next side would be the left side. That's where we'll put our first electron. So 1, 2, 3, 4, 5, 6, and 7. And that leaves the unpaired electron on this fluorine facing the unpaired electron on silicon. Okay, so now that we've drawn each atom and the valence electrons around each atom, we can take stock of which electrons are unpaired. Now on silicon, there are 4 electrons that are unpaired. On each fluorine, there is 1 electron that is unpaired. So what we can do is combine these unpaired electrons to pair them up and make them more stable. So those 2 electrons on the right, we can pair them up as a bond. On the bottom, we can pair them up. On the left, we can pair them up. And at the top, we can pair them up. And now, those 2 electrons that are being shared in each of those cases are making those atoms stick together, bind together, so that we can redraw them as single lines that are representing that bond. So instead of those 2 electrons, we can put a line. We replace the 2 electrons with a line, replace the 2 shared electrons with a line, replace the 2 shared electrons with a line. Each of those lines represents 2 shared electrons, and they're called bonds. So this is the electron dot formula for SiF4, which is a clear gas. So if you were to take silicon and react it with fluorine in just the right way, you would get this molecule of SiF4. And it's often released in the plumes above volcanoes. How about for CH4? Let's try to draw the electron dot formula for that. So first we have one carbon, so we'll draw C, the symbol for carbon. Then carbon is in column 4A, so it's going to have 4 valence electrons. So we'll put one on each side of the symbol. So 1, 2, 3, 4. Now we have 4 hydrogens. I'm going to put the hydrogens on each side of carbon that has an unpaired electron. So 1, 2, 3, 4. Hydrogen is in column 1A, so it has just 1 valence electron. So on each hydrogen, I'm just going to put 1 dot, and I'm going to put that dot on the side that's facing the carbon. So 1, 1, 1, and 1. In terms of unpaired electrons, we have 4 of them on the carbon, and we have 1 on each of the hydrogens. So to make all of these atoms more stable, each of these unpaired electrons more stable, we can start pairing them up. So these 2 electrons on the right can be paired up, on the bottom they can be paired up, on the left they can be paired up, and on the top they can be paired up. And these shared electrons bind the 2 atoms, each of the atoms together, and create a bond. So we can redraw those 2 shared dots as a line. So replace those 2 dots with a line, those 2 dots with a line, those 2 dots with a line, and those 2 dots with a line. And that is the electron dot formula for CH4. CH4 is a molecule called methane, and a certain type of bacteria called methanogens often break down decaying organic matter and release methane. Sometimes the methane is released in bubbles, so if creatures die in lakes, they go to the bottom, and these microbes, methanogens, will release methane, and as the lake freezes, in this example it's Abraham Lake in Canada, the bubbles of methane will freeze in the ice. These creatures, these microbes that produce methane, also live underneath soils, including underneath the permafrost in Siberia, and they can produce huge amounts of methane that then get trapped underneath that solid layer of permafrost and create these sorts of bubbles coming up from the ground. They can pop and create huge holes. Methane is also unsavourily released in the flatulence of cows, and as methane is 25 times more potent of a greenhouse gas than carbon dioxide, and so it being released by so many cows in the world raises the temperature of a climate. And also, methane is present in liquid form on one of Saturn's 62 moons, the moon Titan. So you can see it here. In images, here you can see the lakes of methane evaporating into clouds. So if you were to take carbon and mix it together with hydrogen, you would get methane, which has the electron dot formula that we drew earlier. Thank you so much for your attention.